Hello, favorite students. Welcome back to another episode of YouTube Physics with Mr. Peacock. Today we're talking about projectiles. I'm here on our notes pack talking about projectiles. We're going over the example problem, which is also going to be your quiz question. In this problem, we have a cliff and we have a ball that we kick off the cliff perfectly horizontally. So all of the velocity is in the x direction. As you can see, I have that drawn here. That ball is going to fly off the cliff and eventually hit the ground. And the question wants to know, how far from the cliff does the ball hit the ground? Now, we talked about in class how x and y, all the motion in the x direction, all the motion in the y direction, are completely independent. They don't hang out. But there is one thing that connects them, the time. So the time it takes for the ball to fall this 100 meters is the same amount of time it takes to go this distance x. So the one thing that is the same is time. Velocity doesn't change, acceleration doesn't change in the x and the y direction, but time links them together. So our steps are going to be to use the y direction to find time and to use the x direction to then solve the problem. So we're going to set up our OK team method in the y direction. And I'm going to start with what I know. I know that my starting position is going to be 100 meters because I'm at the top of the cliff. We've been doing position as x, but since we're going in the y direction here, it becomes y. I'm going to do my final position as 0 meters. I know that my starting velocity in the y direction, careful, this is not velocity, it's velocity in the y direction, the part that's going up and down. I know that that is 0. My ball gets kicked straight off of the cliff, so there is no velocity to start in the y direction. So that is 0 meters per second. And then I know that my acceleration in the y direction is negative 9.8, or the AP test lets us use negative 10 meters per second. And what I'm trying to do is find the time. Time is my target, so that I can then take that time and link them together and solve in the x direction. So time is my target right now. So I'm going to look for an equation that has all of my knowns and my target, and I'm going to use our second equation. Final position equals starting position plus the initial velocity in the y direction times time plus 1/2 the acceleration in the y direction times time squared. And I'm going to take the things that I know are 0 and I'm going to plug them in so I can cancel them out. So I know that my final position is 0. I know that my velocity to start in the y direction is 0. So I have 1/2 a y t squared. Now I'm trying to get time by itself. So I've got to first subtract this initial position to the other side. So I'm going to have negative initial position equals 1/2 acceleration times time squared. Then I'm going to multiply both sides by 2 to cancel out. So I'll have negative 2 initial position equals a t squared. Trying to get t by itself, so I have to divide by a, and I have negative 2y naught over a equals t squared. And then I have to get t by itself, So I'm going to do the opposite of square, and I'm going to take the square root of both sides. So the square root of -2 initial position over acceleration equals time. That is, in variables, my final answer. And then I'm going to plug in my numbers. The square root of -2 times positive 100 divided by -10 equals time. And then I'm out of space, so I'm going to bring this back up. And then I have the square root of -200 over -10 equals time, which then gives me the square root of 20 equals time, and the square root of 20, here's the calculator, gives us 4.47. Time equals 5 seconds. 4.5 seconds is the time it takes to hit the ground. Now we have to do the x direction, because we're going to use the x direction to find this distance. So, x direction. We know our time is 4.5 seconds. We figured that out here. We know that our initial velocity in the x direction is 50 meters per second, because it's given to us in the problem. We know that our starting position is 0 meters, because we start here at the base of the cliff, here at 0. Acceleration is equal to 0 meters per second, because when we have a flying object or projectile, there's acceleration in the y direction, but there's no acceleration in the x direction. So acceleration is 0, and our target is final position. So we're looking for an equation that has all of these pieces that we know and our target. And we're actually going to use the same equation. So equation number 2, the final position equals the starting position plus the initial velocity times time plus 1/2 the acceleration times squared. And then we're going to plug in zeros for the thing that we know are zeros. So our final position equals 0 plus our initial velocity in x multiplied by time plus 0, because our acceleration is 0. Which means our final position is equal to the initial velocity in x multiplied by the time. So that is our final answer in terms of variables. And then our final position is going to be 50 multiplied by 4.5. And that is going to give us 225. So, if we have a ball at the top of a 100-meter tall cliff, and we give that ball some velocity in the x direction of 50 meters per second, it's going to land 225 meters from the base of the cliff. We used the y direction to find time, and that time is connected to the x direction, and then we used that time to find the final position.